For the very last trick today, I'm going to look at this rational function. The function I've got is 3 plus h squared minus 9 divided by h. Now, this is a little bit different because I'm using h as my variable instead of x, and that's fine. We can do that. And the other problem I see here is that this is a rational function, which is supposed to be one of my very nice direct substitution functions, except my h is going to 0. And that's exactly when I said I can't do direct substitution. I can't put in h equals 0 in this formula. But I'm not sunk. What I'm going to do for this rational function is I'm going to expand the numerator and see what I get. I'm still working inside of my limit. So I'll say that this is 3 squared plus 6h plus h squared minus 9, the whole thing divided by h. Right, so there I've performed my foiling. And 3 squared will cancel exactly with that 9. I'm left with 6 times h plus h squared, all of it divided by h. Limit h goes to 0. Well, cool. Now this is still a rational function, and the coordinate h equals 0 is not in its domain. So strictly speaking, I've got to be careful here. And I've got to say I'm taking the limit as h goes to 0, and I'm going to factor to say the numerator has an h in it, the denominator has an h in it. I'll put that by itself. What do I have left over? 6 plus h. Right? All I've done is I've factored out that numerator. Now, if I'm being super strict with myself, I'm going to say that my limit laws allow me to break the limit into 2 different pieces and then multiply the answers together so long as they exist separately. That's the very strict interpretations of these rules. You can probably guess what's going to happen over here. For this limit, my variable is h. This is a polynomial, right? It's a degree 1 polynomial. So I can use my direct substitution and say that this limit on the right side is 6 plus 0. Very nice. I'll be multiplying that over here. So what is the limit of this rational function? None of my limit laws tell me how to manage, again, I have this 0 over 0 situation. But what I'm going to do is I'm going to draw a sketch of what this function looks like. So I guess this is the hy plane. For any value of for any value of h greater than 0, h divided by itself is going to give me a value of 1. So this is h equals 1. For any value of h which is negative, same answer. But I'm going to have a hole in my graph. This formula is undefined at h equals 0. But that's okay because I'm taking limits. So I'm not going to use a limit law here. I don't have a limit law for holes in the function. I have to use my graphical reasoning here to say that as my h gets closer and closer and closer to 0, my y remains close to y equals 1. In fact, it's a quirk of this kind of function that the y isn't deviating at all. There's just the one spot where the function fails to exist. So with that rationale that the y-coordinate is not deviating away from the coordinate 1, this limit is going to equal 1, and we have effectively canceled out those h's from my rational function. So for this limit, I get 6.